Introduction. Amines are the organic compounds that are formed by replacing hydrogen atoms of ammonia molecule by alkyl or aryl groups. For example, dithylamine. Amines can be classified into primary amine, secondary amine, and tertiary amine. Diazonium salts are the organic compounds with general formula Rn2 plus X-, where X- is chloride ion, bromide ion, etc. Diazonium salts are used to manufacture azo dyes. In this lesson, we will learn more about amines and diazonium salts. Objectives. At the end of this lesson, you will be able to explain structure of amines, classify amines, describe nomenclature of amines, describe preparation of amines, describe physical properties of amines, explain chemical reactions of amines, explain method of preparation of diazonium salts, explain chemical reactions of diazonium salts. Amines. Amines are formed by the replacement of 1, 2, or 3 hydrogens of ammonia by alkyl or aryl groups. Structure of amines. The bonding in alkyl amines is similar to the bonding in ammonia. The nitrogen atom is sp3 hybridized with the 3 substituents occupying 3 corners of a regular tetrahedron and the lone pair of electrons occupying the 4th corner. The C-N-C bond angle is very close to 109 degree. For example, 108 degree in trimethylamine. Classification. Amines can be categorized on the basis of number of hydrogen atoms changed by alkyl or aryl groups in ammonia molecule. Primary amine, that is 1 degree, secondary amine, that is 2 degree, and tertiary amine, that is 3 degree. When one hydrogen atom of ammonia is replaced by alkyl or aryl group, the compounds formed are called primary amines. Their general formula is RNH2 or ARNH2. When 2 hydrogen atoms of ammonia are replaced by 2 alkyl or aryl groups, the compounds formed are called secondary amines with general formula R2NH. When all the 3 hydrogen atoms of ammonia are replaced by 3 alkyl or aryl groups, the compounds formed are called tertiary amines with general formula R3N. Secondary and tertiary amines can be further classified into 2 categories, namely simple amines and mixed amines. If the alkyl or aryl groups bonded to nitrogen atom are same, the amine is called simple amine. However, if alkyl or aryl groups bonded to the nitrogen atom are different, the amine is called mixed amine. Nomenclature. In common name system, alkyl amines are named as alkylamines. To obtain the name, the word amine is added to the name of alkyl group present in the molecule. In case of mixed secondary and tertiary amines, the names of alkyl groups are written in alphabetical order. In IUPAC system, primary alkyl amines are named as alkenamines by replacing the final E of the name of the parent alkane by the suffix amine. If more than one amino group is attached to different position in the parent chain, then their locations are specified by providing numbers to the carbon atoms bearing amino group. The letter E of the hydrocarbon part is retained. The simplest arylamine is aniline and it is also considered as IUPAC name. In IUPAC system, suffix E of arene is replaced by amine. Preparation of amines. Reduction of nitro compounds. The reduction of nitrobenzene in acidic or neutral solution results in the formation of aniline. Nitrobenzene is reduced to aniline by passing hydrogen gas in the presence of finely divided palladium. Ammonolysis of alkyl halides. The process of cleavage of the CX bond by ammonia molecule is called as ammonolysis. If alkyl halide is in excess, the primary amine formed further reacts with alkyl halide to form secondary amine, tertiary amine, and finally quaternary ammonium salt. The reactivity of the various halides decreases in the following order, that is Ri followed by Rbr followed by RCl. Preparation of amines. Reduction of nitriles. The reduction of alkyl nitriles with lithium aluminium hydride or catalytic hydrogenation form primary amines. Reduction of amides. Amides are reduced to corresponding amines by lithium aluminium hydride. Preparation of amines. Gabriel phthalamide synthesis. In this process, phthalamide is reacted with alcoholic KOH to get potassium phthalamide, which reacts with alkyl halide to form N-alkyl phthalamide, which on basic hydrolysis gives primary amine and phthalic acid. Phthalamide reacts with alcoholic KOH to get potassium phthalamide, which reacts with bromoethane to form N-ethyl phthalamide, which on basic hydrolysis gives ethylamine and phthalic acid. Hoffmann bromamide degradation reaction. When a primary acid amide is heated with an aqueous or ethanolic solution of NaOH or KOH and bromine, it gives a primary amine with one carbon atom less. Physical properties. The methylamine and ethylamine are gases at room temperature and have ammonia-like odors. Most other amines are liquids and many have odors resembling that of raw fish. Low molecular weight amines are soluble in water because they can form hydrogen bonds with water molecule. With the increase in molecular mass of amines, the solubility decreases due to increase in the hydrophobic alkyl part. Primary and secondary amines have higher boiling point than hydrocarbons of comparable molecular weight because of hydrogen bonding with other amine molecules. For example, propane, whose molecular weight is 44, boils at -42 degrees Celsius, while ethylamine, whose molecular weight is 45, boils at +17 degrees Celsius. Tertiary amines cannot make hydrogen bond with other amine molecules because of the absence of hydrogen bonded to nitrogen. Chemical reactions. Due to the difference in electronegativity of nitrogen and hydrogen atoms of amines and the presence of unshared pair of electron makes amines reactive. As the number of hydrogen atoms present in primary, secondary and tertiary amine are different, so their chemical reactions also produce different compounds. Basic character of amines. Amines exhibit basic character due to the presence of a lone pair of electrons on nitrogen. They are stronger bases than water and are therefore protonated by water in their aqueous solutions. Amines' basic character can also be described in terms of Kb and pKb values. The value of K can be written as, from which value of Kb can be inferred as given. Now pKb is equal to negative logarithm of Kb. Greater Kb value or smaller pKb indicates stronger base. Structure, basicity relationship of amines. Alkenamines versus ammonia. All alkyl groups are electron releasing. Due to electron donating inductive effect, that is positive I effect of alkyl groups, electron density increases on nitrogen so that protonation becomes easier. This also increases basic character. Moreover, the electron releasing effect of alkyl groups stabilizes the alkyl ammonium cation formed, and therefore equilibrium shifts in the forward direction, making alkenamines stronger base than ammonia. Amines can easily be protonated by water in their aqueous solutions. Among primary, secondary and tertiary amines, the electron releasing effect increases from primary to secondary to tertiary amine. Therefore, the base strength of alkenamines is in the order tertiary amine followed by secondary amine followed by primary amine. This order of basic character of alkenamines is true in gas phase. The order of basicity in aqueous solution does not follow the above trend. The secondary amines are invariably found to be stronger bases than primary amines, but the tertiary amines are found to be weaker than secondary amines and sometimes even weaker than primary amines. For example, the basicity order of methyl and ethylamines is as under. Arylamines versus ammonia. The arylamines are much weaker base than ammonia and aliphatic amines. In aniline or other arylamines, NH2 group is linked directly to the benzene ring. Due to resonance effect, the unshared pair of electron on nitrogen is delocalized into pi electron system of the ring. Resonating hybrid structures of aniline are as follows. In the above resonating structures, there is a positive charge on nitrogen atom, making the lone pair less available for protonation. Hence, aniline is less basic than ammonia and aliphatic amines. Acylation. Aliphatic and aromatic primary and secondary amines containing replaceable hydrogen atoms by reacting with acid derivatives such as acid halides or anhydrides undergo acylation through nucleophilic substitution to form amides. Acetyl chloride reacts with ethylamine in the presence of base and form intermediate which forms an ethylethanamide and hydrochloric acid. Acetyl chloride reacts with diethylamine in the presence of base and forms N-diethylethanamide and hydrochloric acid. Acetic anhydride reacts with aniline in the presence of sodium hydroxide and forms acetanilide and acetic acid. Chemical reactions. Carbylamine reaction. Primary aliphatic and aromatic amines, when warmed with chloroform and alcoholic solution of potassium hydroxide, give very unpleasant smell of isocyanides. Chloroform and alcoholic solution of potassium hydroxide reacts with methylamine and form methyl isocyanide, potassium chloride and water. Reaction with nitrous acid. Primary aliphatic amine reacts with nitrous acid to form Dizonium salt, but that is unstable. Therefore, they decompose to form alcohol, hydrochloric acid, and liberate nitrogen gas. Aniline on reaction with nitrous acid in the presence of sodium nitrite and hydrochloric acid at 0 to 5 degrees Celsius form benzene diazonium chloride, sodium chloride and water. Reaction with aryl sulfonyl chloride. When ethylamine reacts with benzene sulfonyl chloride, also called Hinsberg's reagent, it forms N-ethylbenzene sulfonyl amide, which is soluble in aqueous potassium hydroxide. When dithalamine reacts with benzene sulfonyl chloride, also called Hinsberg's reagent, it forms N-dithalbenzene sulfonamide, which is insoluble in aqueous potassium hydroxide. Tertiary amines do not react with benzene sulfonyl chloride, that is Hinsberg's reagent. Electrophilic substitution. Bromination. Benzene ring is so highly activated in aniline that when aniline is treated with bromine water at room temperature, substitution takes place at all the ortho and para positions, resulting in the formation of a white precipitate of 2,4,6-tribromoaniline. To obtain mono-substituted product, the strong activating effect of NH2 group has to be decreased before carrying out the desired substitution. This is done by acetylating aniline before the substitution reaction. This is called protection of the amino group. Aniline reacts with acetic anhydride and pyridine and form acetanilide. Now add bromine water and acetic acid and it produces para-bromoacetanilide, and then followed by hydrolysis yield para-bromoaniline. Nitration. Nitration is carried out with nitric acid, which is not only nitrating agent but also a strong oxidizing agent. Therefore, direct treatment of aniline with nitric acid leads to oxidation of highly activated benzene ring, resulting in the formation of complex terry-oxidation products. Nitration of aniline can be controlled by protecting the NH2 group by acetylation reaction. Aniline reacts with acetic anhydride and pyridine and form acetanilide. Now add concentrated nitric acid and sulfuric acid at room temperature and form para-nitroacetanilide, and then followed by hydrolysis produces para-nitroaniline. Sulfonation. Aniline on reaction with sulfuric acid results in the formation of anilinium hydrogen sulfate. Heating this anilinium salt yields para-aminobenzene sulfonic acid, properly known as sulfanilic acid. Aniline reacts with sulfuric acid and form anilinium hydrogen sulfate, and then heating the anilinium ion at 180 to 200 degrees Celsius, it forms sulfanilic acid. Sulfanilic acid exists as a dipolar or Zwitter ion. Diazonium salts. The general formula of diazonium salt is Rn2 plus X minus, where R stands for aryl group and X minus is chloride ion, bromide ion, hydrogen sulfate ion, tetrafluoroborate ion. The N2 plus group is called Diazonium group. For example, C6H5N2 plus Cl minus, that is benzene diazonium chloride. C6H5N2 plus BF4 minus, that is benzene diazonium tetrafluoroborate. Arene diazonium ion is stable due to the following resonating structures. Method of preparation of diazonium salts. Aromatic diazonium salts are usually prepared at low temperature by adding cold aqueous solution of sodium nitrite to the solution of primary aromatic amines with an acid like hydrochloric acid or sulfuric acid, because nitrous acid being unstable is prepared in situ. The reaction which converts a primary amine into its Dizonium salt is known as Diazotization. Aniline reacts with cold aqueous solution of sodium nitrite and hydrochloric acid at 273 to 278 Kelvin, and it produces Diazonium salts. Diazonium salt is unstable, therefore cannot be restored. Physical properties. Arene diazonium salts are generally colorless, crystalline solid, highly soluble in water. Generally, diazonium salts are unstable above 5 to 10 degrees Celsius and many explode when dry. Chemical reactions. Reactions involving displacement of nitrogen. In these reactions, molecular nitrogen acts as a leaving group and is replaced by another atom or group such as chloride ion, bromide ion, iodide ion, cyanide ion, and hydroxide ion. Replacement by halide or cyanide ion. Arene diazonium salt, when treated with cuprous chloride, cuprous bromide and cuprous cyanide, give aryl chloride, aryl bromide and aryl cyanide respectively. Benzene diazonium chloride reacts with hydrochloric acid and cuprous chloride and yield aryl chloride and evolves nitrogen gas. Benzene diazonium chloride reacts with hydrogen bromide and cuprous bromide and yield aryl bromide and evolves nitrogen gas. Benzene diazonium chloride reacts with potassium cyanide and cuprous cyanide and yield aryl cyanide and evolves nitrogen gas. These reactions are known as Sand-Mears reactions. Gettermann reaction. In these reactions, benzene diazonium chloride is treated with halogen acids in the presence of copper powder. Benzene diazonium chloride reacts with hydrochloric acid and copper powder, yield aryl chloride, cuprous chloride and liberate nitrogen gas. Benzene diazonium chloride reacts with hydrogen bromide and copper powder, yield aryl bromide, cuprous chloride and liberate nitrogen gas. Replacement by iodide ion. Benzene diazonium chloride reacts with potassium iodide and yield iodobenzene, potassium chloride and evolves nitrogen gas. Replacement by fluoride ion. Benzene diazonium chloride reacts with fluoroboric acid and yield benzene diazonium tetrafluoroborate, then on heating it produces fluorobenzene, boron trifluoride and evolves nitrogen gas. Replacement by H. Benzene diazonium chloride reacts with hypophosphorus acid and water, yield benzene, phosphorus acid, hydrochloric acid and evolves nitrogen gas. Replacement by hydroxyl group. Benzene diazonium chloride gets hydrolyzed when some heat is provided and produces phenol, hydrochloric acid and evolves nitrogen gas. Replacement by nitro group. By heating diazonium fluoroborate with sodium nitrite in the presence of copper powder, the diazonium group is replaced by nitro group. Reactions involving retention of diazo group. Coupling reactions. Arene diazonium ions are relatively weak electrophiles but have sufficient reactivity to attack strongly activated aromatic rings of phenols and tertiary arylamines. The reaction is known as azo coupling. Benzene diazonium chloride reacts with phenol in the presence of sodium hydroxide and water at 0 degrees Celsius, produces parahydroxyazobenzene. Benzene diazonium chloride reacts with aniline in the presence of sodium acetate and water at 0 degrees Celsius, produces para-aminoazobenzene. Importance of diazonium salts in synthesis of aromatic compounds. Diazonium salts are very good intermediate for preparing a variety of organic compounds. For example, aryl fluorides and iodides cannot be prepared by direct halogenation, but they can be easily prepared through diazonium salts. Did you know? Cadaverine and putrescine. These are the foul-smelling organic chemical compounds produced by the breakdown of amino acids in living and dead organisms, and both are toxic in nature. Summary. Let us summarize what we have learned. Amines are formed by the replacement of 1, 2 or 3 hydrogen of ammonia by alkyl or aryl groups. Amines can be categorized into primary amines, secondary amines and tertiary amines. In common name system, alkylamines are named as alkylamines. In IUPAC system, primary alkyl amines are named as alkenamines. The methylamine and ethylamine are gases at room temperature and have ammonia-like odors. Low molecular weight amines can form hydrogen bonds with water molecule. Amines exhibit basic character due to the presence of a lone pair of electrons on nitrogen. The general formula of diazonium salt is Rn2 plus X minus, where R stands for aryl group and X minus is chloride ion, bromide ion, hydrogen sulfate ion, tetrafluoroborate ion. The N2 plus group is called Diazonium group. Diazonium salts are very good intermediate for preparing a variety of organic compounds.